What is the consequence of aliasing? We should put it down very clearly. Aliasing does two things. One frequency manifested as another. Two, increasing actual frequency leads to decreasing apparent frequency. So, in fact, just to emphasize, let me put back before you and stress this point. As you increase the frequency from 0 to pi by 2 here, the frequency appears to decrease from pi to pi by 2 there. Now, the first thing we have to do if we want perfect reconstruction is to do away with aliasing. So, we put down a condition for aliasing cancellation. If we want y z to reconstruct x z, we must first do away with aliasing. And how can we possibly do away with aliasing? That essentially means we want tau 1 z to be equal to 0, or in other words, we want g 0 z h 0 minus z plus g 1 z h 1 minus z equal to 0. And in fact, if we wish to explicitly express the synthesis filters in terms of the analysis filters, we could do that as well. Let us rearrange this equation to get g 1 z by g 0 z is minus h 0 minus z by h 1 minus z. And of course, a very simple choice is g 1 z equal to the numerator, let us say plus or minus h 0 minus z, and correspondingly g 0 z is minus respectively plus h 1 minus z. This is a very simple choice of synthesis filters from the analysis filters, which can give us alias cancellation. Now, in fact, we can even spend a minute in interpreting what we have just said here in this very simple choice. I must of course emphasize, this is a simple choice, but definitely not the only choice. In general, you should note that there would be a factor cancelled in the numerator and denominator. So, more general choice would be as follows. G 1 z is of the form plus minus some factor, let us say r of z times h 0 minus z, and g 0 z is respectively minus or plus r z h 1 minus z. So, r z is in some sense the factor cancelled. When you divide g 0 z by g 1 z, some factor has been cancelled and what is left is h 0 and h 1. That is the way you should look at it. That is the more general situation. Anyway, now let us interpret what we had written here, namely g 1 z, this is a very simple choice of g 1 is h 0 of minus z and g 0 is plus or minus, you just interchange plus or minus here, h 1 of minus z. So, let us take the upper one, g 1 z is h 0 minus z, the other one follows similarly. You see, ideally, this is what the frequency response of h 0 should be. It should be an ideal low pass filter with a cutoff of pi by 2. So, this is what the frequency response should look like. This is 1, the height here. So, what would h 0 e raised to the power omega j omega plus minus pi look like? Or in other words, what is h 0 of minus z then? H 0 minus z with z replaced by e raised to the power j omega is essentially, of course, as you know, h 0 e raised to the power j omega plus minus pi. And that, as you can very easily infer, looks like this. Again, let us use the strategy of zooming and then contracting back again. So, I have pi minus pi there, 2 pi, 3 pi and so on. This is what h 0 look like, taking note of the periodicity, remember. This is minus pi by 2 there, this is pi by 2, this would therefore be 3 pi by 2 and so on. So, the zoomed h 0 e raised to the power j omega plus minus pi would look like this. It would have an appearance like this. And so on here. These pass bands, so to speak, are now going to lie at the odd multiples of pi, and you can continue that drawing. Now, once again we confine to the principal interval. So, the principal interval is here. And when we do so and then zoom back to emphasize only the principal interval, what do we get? We get this. Lo and behold, from a low pass filter with a cutoff of pi by 2, we have a high pass ideal filter, of course, again with a cutoff of pi by 2. So, this falls into place very well. In fact, the equation G 1 z is H 0 minus z makes a lot of sense. All that we are saying is that on the synthesis side, if you had an ideal low pass filter with a cutoff of pi by 2 at H 0, you should put an ideal high pass filter with cutoff pi by 2 at the point G 1. And if you look back at the other one of the two, namely G 0, you would make a similar inference. G 0 z is H 1 of minus z with a minus sign. So, if you look at the magnitude sense, again a high pass filter would become a low pass filter. In fact, I leave this to you as an exercise. So, exercise shows similarly that an ideal high pass filter HPF with a cutoff pi by 2 on replacing z by minus z becomes an ideal low pass filter with a cutoff of pi by 2. And that also makes a lot of sense for the other of the two requirements for Elias cancellation. So, today we have looked at the condition for Elias cancellation and we have interpreted the simplest of the conditions. Now, if you do not stick to the simple condition and if you have the factor of R z, all that we need to do is to say that we are also modifying that filter a little beyond just this low pass to high pass and high pass to low pass conversion. That R z factor would carry out that modification. So, we have taken one out of two steps today in building a perfect reconstruction 2-band filter bank. We have taken the step of Elias cancellation. In the next lecture, we shall take the second step, namely perfect reconstruction. So, we have done away with tau z, tau 1 z, but now we need to see what to do with tau 0 z, which we shall do in the next lecture. Thank you.